we have shown that the first law of thermodynamics can be expressed mathematically as du equals dq plus dw. Ang ibig sabihin nito, yung internal energy daw, which is the sum of all kinetic energies and potential energies of all molecules of a system, can be related to the amount of work done on or by the system and the amount of heat transferred to or from the system. So what I'm showing you right now is the differential form, basically, ng first law of thermodynamics. Yung dW or work can be expressed as, so dW equals minus P dV, where P here is actually the external pressure. Now, yung internal energy, function siya ni temperature and volume, which makes sense, right? Kasi the higher the temperature, the greater the internal energy of a system. And ganoon din si volume. Kapag nililitan mo yung volume or nilalakihan mo yung volume, depende, no? Nagkakaroon ng interaction yung mga particles doon sa system, and that interaction will contribute to the internal energy. Now, remember in mathematics, we can derive the total differential. And in this case, we will do that in internal energy. So your total differential, or du, will be, just take the partial derivative of u with respect to the first variable, which is temperature, and gawing mong constant yung volume, so at constant volume, dt, plus partial derivative of internal energy with respect to the second variable, volume, this time at constant temperature, dV. So that's the total differential for your internal energy. Alright? So, kung ang internal energy natin ay, again, let me write that du is again dq plus dw, and dw is minus p dv. So I'm just rewriting these expressions here. Ang gawin natin is substitute natin. So magiging du natin will become dq. So I'm doing it with this equation, minus p external dv. So I just substituted yung expression ni dw. So what I'm gonna do next is I will divide this resulting expression or equation by dt. So divide by differential t at constant v. So what will happen? So again, gagawin ko is I will divide that expression by dt at constant v. I'm talking about this final equation here. So du divided by dt daw. So magiging ano siya? Du dt at constant v daw, equals yung dq, yung next kong i-divide by dt. Again, that happens at constant v. And since constant volume nga tayo, mawawala ang expression na ito. So yan na yung resulta. Now, if you take a look at dq over dt at constant v, siya yung tinatawag nating CV. Okay? So this thing here is called CV. And CV, ang tawag dyan is constant volume heat capacity. Okay? Kasi 'di ba, mayroon kang heat, dQ. So ibig sabihin niyan, may change in temperature, may change din sa heat. And since positive yung derivative, the higher the temperature, gano'n din ang itinaas ni heat. And that happens at constant volume. So that expression is your constant volume heat capacity. Because by definition, heat capacity means gaano kalaki yung change in heat with respect to temperature. So therefore, CV is also equal to the derivative of u with respect to t at constant v. Okay? Because of that equation. So balikan natin yung total differential natin right here. So therefore, du there will become, since partial of u with respect to t at constant v is now equal to cv. Okay? So I'm talking about this one. cv na siya. dt. Pero may natitira kang expression na partial of u with respect to v at constant t dv. So this class is now your general expression for change in internal energy. Okay? Change in internal energy. Now, yung second term, minsan, ina-approximate natin yan to be zero. So, we just ended with the first term. So, what do I mean? Kasi yung second term na yan, which I will write here, yung partial of u with respect to v at constant t, okay, I'm talking about this one, yan yung tinatawag po natin na internal pressure, which we sometimes use the symbol pi. So, ang ibig sabihin niyan, internal pressure. But later on, we will identify ano ba itong ibig sabihin ng internal pressure na ito. Okay? Ngayon, let's talk about perfect gases. So, yung ideal gases or perfect gases, yung kanilang internal energy is approximately function lang siya ni temperature at hindi ng kung ano pa mang property like volume. Okay? Kasi, yes, the higher the temperature, the higher the internal energy. Napatunayan na natin yan. But, if you're going to change the volume, okay, kaso nga lang perfect gas siya eh. So, no matter what you do with volume, lilit man ng lilit yung volume ng system, wala tayong pakialam kasi walang magiging interaction pa rin yung mga particles sa isa't isa. Kasi perfect or ideal gas siya. So, kung ang internal energy ay function lang ni temperature, what will happen with the partial derivative of u with respect to volume at constant t? So, that will be equal to 0. Bakit? Kasi ang variable mo dito is volume, right? So, ibig sabihin, kasama si volume dyan sa expression na yan. It varies. Pero nga, again, for perfect gases, internal energy only varies according to temperature. So, this expression will therefore be 0. So, ang natira na lang dito sa ating expression for internal energy is du equal to cv dt. Okay? Now, if, of course, we will integrate both sides of the equation, integral of du will be just delta u, or change in internal energy, and si integral ni cv dt, edi integral ni cv dt. Kasi, sometimes you just don't integrate cv. I mean, Sometimes it's constant, sometimes it's not. But this is now how you can calculate the change in internal energy of a perfect gas. Okay, take note again, ang pinag-uusapan lang dito, you use this equation for perfect gases. Pinag-usapan din natin last time yung enthalpy. So enthalpy is the work necessary to create a system and give it a room or yung volume. And mathematically, we expressed enthalpy as H equals U plus PV. Okay? So yan po ang definition ni enthalpy na kailangan nating ma-memorize. Now, let's perform some differentiation here. So if I take the differential H, gawin ko rin siya sa right-hand side ng equation. So du din. And then you have a product here. So if you remember the product rule in derivatives, so you'll have P differential V plus V as constant, differential P naman. Okay? Now, naalala nyo na si du equal siya sa, saan nga ba? This one, right? This expression, du is equal to dq minus pdv. So let's do that. Let's substitute that. Du is equal to dq minus p external dv plus pdv plus v dp. Now, mag-assume tayo, no? Let's say na ang pressure is approximately equal to the external pressure. So kapag nangyari yan, we will be able to reduce this expression. So makakancel lang natin yung dalawang term na to. So ang ending, ang differential internal or differential enthalpy natin, dH, will be equal to dQ plus V dP. So yan na po ang differential form ng ating enthalpy. Now, I'll do the same thing with what I did dun sa internal energy. So what will I do is I will divide this equation. Okay, divide by dt din at constant pressure. So if that happens, magiging, di ba? Magiging dH siya over dt at constant P daw. And yung dq naman, i-divide ko rin by dt at constant pressure. Now, since I'm doing that at constant pressure, yung term na ito, this one, will vanish. dP will be equal to 0 kasi constant pressure tayo. Pressure will not vary. Now, tignan nyo tong term na to, yung dQ dt at constant P. Change temperature, may change din sa heat. This time at constant pressure. So, therefore, heat capacity din yan. And we will call it Cp kasi Cp this time is yung ating constant pressure heat capacity. Okay. Let's say na si enthalpy ay function siya ni temperature tsaka pressure. Tama naman, di ba? Kasi the higher temperature, the higher the enthalpy. Remember, enthalpy is just the collection of U, which is also a function of temperature, and PV. And we also include pressure. Now, let's do the total differentiation again. So, mangyayari dH is equal to the change in H with respect to the first variable temperature at constant pressure, which is the second variable, dt. Plus, ang i-vary naman natin, okay, yung second variable, so with respect to pressure this time, at constant T, dP. Okay. But what is this term here? Yung partial of H with respect to T at constant P. Di ba siya yung Cp? Okay, so therefore, ang dH natin magiging Cp dt. And then, of course, you still have the remaining term, partial H with respect to P at constant T dP. So, ito na po ang magiging expression natin to calculate the change in enthalpy. Okay? So, please remember this, or better, derive this equation. So, you have two now. Yung ating change in enthalpy, tsaka yung ating change in internal energy. But let's do the same treatment. Paano kapag meron kang perfect gas or ideal gas? So for ideal gas, ganoon din ang ating enthalpy, it's a function, okay, approximately function siya ni temperature and not of pressure. So kung ganon, yung expression or term na partial of H with respect to P at constant T, which is this one, right? Since P is a variable here, eh sabi natin, temperature lang, nakadepende yung enthalpy. So therefore, this one will be 0. So anong matitira sa ating equation? So yung equation na to, magiging differential H equals Cp dt na lang. And if we're going to integrate, we'll be able to arrive at this equation. Change in enthalpy delta H equals the integral of Cp dt.